I'm Jonathan here at Humanoids Summit, and I'm with Kazuma from Haptica, and she's doing some really interesting things with Haptic. So, Kazuma, tell me, what do we have here?
So what we have here is a textile-based sensor and actuator or feedback. So what it does is it has essentially little inflated balloons in the fingertips that are able to sense differences in pressure. If I press on a fingertip and you have a look at the screen, you'll see that it's able to detect pressure changes really finely. And not only is it doing that, it's feeding it forward to the other glove. Meaning if I put a system like this on a robot, I would have all of the touch information, and by giving this to a human, they'll be able to feel that in real time.
Okay, interesting. And so then, like, what type of robots would we see this on?
Any type.
Any type?
It's what we call platform agnostic.
Okay.
Because it's textiles, it literally means that we can make whatever shape we want. So it can be for a 2-finger gripper or a robotic hand or even something else. If you just want a bumper on your robot, for example, all of that works.
So then the importance here of having the touch is like, I think we live our lives touching things every day. We don't think about it, but it's probably a sense that it's just automatic in how we interact with things. So like I touch something, I don't know how hard to squeeze, things like that. And so that's really important to transfer that. If I want to do teleops to train a robot, that I have that feedback. Or eventually maybe you don't need the gloves to train it, but it still needs that sense because it's not just looking at something and saying, I know exactly how hard to grip that object.
Exactly. Like think of an egg or a glass, right? How is it going to know how hard to grip it if the glass is slightly different from all the other glasses it's seen?
Right. That'd be terrible if you if you broke some glasses, like maybe one of these home assistant robots,
If your home assistant robot broke 1 out of 2 of your glasses, that would be an issue. Even 1 out of 10 would be an issue, right? And so what we've done, so I'm out of Stanford, and what we've done is we've put these sensors on robots and given, we had 30 people run through our user study that, you and me, like everyone, come in, do our study, and what we were able to show is that by turning on haptic feedback, they were much more efficient in the way they moved, they were faster, they applied less force. And what we're seeing now, everyone is about AI. What we're seeing is that in the models that we're training on that data, they're much more accurate and they're much more gentle.
Well, it gives it another input where it can use to decide how hard, how strong, how long. That's really interesting. And so, again, this is agnostic. You can just integrate with any robot. If someone wanted to get started with this, maybe they're in the design phase, figure out the right sensors combination. So we're just starting out. So what we're trying to find is what are the really valuable use cases? Where is this really needed to unlock a new use case? So people who are working with robotic platforms who need touch sensing or teleoperation, both, can just get in touch with us and we'll take it from there.